At the beginning of last century, EVs were 40% of the auto market. Why did it not evolve over the next 100 years that everyone sells EVs? Why would we even want to have EVs? Is there a reason? Is there a good reason? All of that we want to answer in this video. So let's get started. Looking at the blog post from Tim Urban from June 2015. This is part of a video series where Tim Urban wrote about Elon Musk and his ventures in 5 parts. The second one is Tesla, which is this video. Then the next one will be SpaceX. Then it will be around Elon Musk himself, the way of thinking and the way of acting. And then the last one will be about Neuralink. So let's get started. Tim first describes here that in a very long post like this, he asks himself what he knows about this topic. Then he reads about the things that he doesn't know or doesn't fully understand. And he finds the foggy spots in his thinking and in his understanding. And then he looks closer at these foggy spots and he keeps on digging until he hits the floor. And before he really digs into the topic, he makes 2 things clear: that this is a highly politicized issue and that he doesn't have any political agenda, and that the post is pro-Tesla, but that he wasn't pro-Tesla from the beginning when he researched the topic, but that he just finds that it makes sense. So let's start with energy. What is energy? Tim Urban describes it as the thing that lets you do stuff. Almost all of the energy on Earth comes originally from the sun, because even us, we eat plants, or if we eat animals, then the animals eat plants first, and they get all the energy through photosynthesis, and this is all due to the sun. So the sun is the origin of almost all of our energy. And he describes that humanity got cleverer and cleverer over time to make use of this energy. He calls it the joules. We want to make use of all the joules that are available. That we make use of them by using animals for our purposes. And then also he said that a very big step up is how we tamed the dragon of fire, that we were able to use fire for our advantages. And the way we really made use of fire was by using steam. So we warmed water up to the point that it evaporated, and then we could use the thermal energy joules of the fire and use the powerful jet of steam, and we could control that. Then the steam engine came out of that. And in the end, the Industrial Revolution was powered by fire, as he puts it, because that's the original source of energy. Then, because of that hype, because of that economical output and incentive, we also found coal, and then after that also natural gas and crude oil. And at the hype of all of this innovation, the really big innovation was in the 1880s. It all came together and they call it electrical energy. So with this, a really big explosion of innovations came. As he puts it, if steam had tamed the dragon, electricity had turned the dragon into a magical butler forever at our service. And because these newfound coal and gas and crude oil were much more efficient, it was even up to that day in 2015 that most of the energy used was still fossil fuel based. The basic problem with this, he describes like this: renewables are in the cycle all the time. These are tools that, for example, a tree grows and then the tree dies, and this is all in the cycle of life. But the problem with the fossil fuels is that this comes from energy that has been buried underground over the last thousands and millions of years. And by burning them, you release all of this energy and all of these chemicals into the atmosphere. So this is not in the natural cycle as it would have been over the last hundreds of thousands of years. He puts it like this: fossil fuels are called fossil fuels because they are the remains of ancient living things. The largest portion of our fossil fuels comes from plants, animals, and algae that lived around 50 to 300 million years ago, and during which there were a lot of huge, shallow swamps. And he describes the swamps as very important because that way the dead organisms would be preserved and could still be used today as a source of energy. But what now is the reason really that burning these fossil fuels is bad? Tim Urban says that combustion is basically a reverse photosynthesis. So all the energy that is stored will be put in the air again. And as I already said before, normally this is a cycle, the carbon cycle, that the carbon flows from the atmosphere into these plants and animals, and then into the ground and the water, and it's a cycle. But then the problem is that sometimes a small portion of that drops out of this cycle over time, over millions of years. So it doesn't decay normally, but it is buried underground and it stays there. And what we do when we burn these fossil fuels is put them up into the air again. Then he goes on to show a graphic that the CO2 levels rose over the last 50, 60 years. But I think the most convincing graphic is this one. Through ice drilling technology, you can see how the CO2 levels were over the last 400,000 years. And you can see that there are a lot of fluctuations. There are also ice age cycles and so on. But then here, when the humans had the Industrial Revolution, here it spikes up to crazy levels that were never seen before. So over the last 400,000 years, it fluctuated between 200 and 300 approximately. And then in the Industrial Revolution, it went almost up to 400. And then the problem that follows from that is that if CO2 levels rise, also the temperature rises. This is the fact too he describes here. And he shows that also through the ice drilling technology, you can see the temperature as well. And if you compare those two lines, I mean, they are almost identical. He describes it more in detail of why this makes sense, that it's a causal effect. But let's move on for now. Why is that a problem? Well, he describes that it doesn't need too much of change to be really shitty on Earth. So the green arrow here is today. The black one here is before the Industrial Revolution. And when it would be 5 degrees below today, New York would be under 800 meters of ice. And if it's 6 to 10 degrees above, New York would be 150 meters underwater. So all of this was the problem that climate change is real and global warming is real. The next point of him is that fossil fuels are endful. So it also kind of makes sense, right? At some point, we will run out of fossil fuels. And even if we have not run out completely, if there's very little left, then it will be more and more expensive because it will get harder to extract these materials out of the ground. Then he continues and he basically says that right now we are in the fossil fuels era since 1800, and we have to get to the sustainable energy era. And the only question is when we will get there. And because it's better to get there sooner than later, the question is how. So he goes on and shows a lot of energy flow charts from different countries and really digs deep into it. Don't want to go through everything now, but he says that this is the US chart from 2013, and the two red dots are a very big problem. It's 72% of total US emissions, and it's the electricity production, which is up here, and that the transportation needs a lot of energy. And since the energy generation is not the focus of this video and this blog post, we will zoom in on this part of the transportation side. So now to the second part, the story of cars. I don't want to go too much into detail, but the first car that was self-propelled was made in 1672. It didn't have a driver yet though. This car 100 years later had a driver and was also powered by steam. Then in 1807, the first internal combustion engine car was made. And the first really useful car was made by Benz in 1886, which looked like this. It cost $1,000, which today, or in 2015, would have been $26,000. So today it would probably be $35,000 or something. But then came along Ford, and he really made a big improvement with the Model T, which was the first mass-produced car. But I think the crazy part is that before the Model T came along, gas cars were only a fifth of all the cars that were sold. I have a quote here from the blog post. Ford and his new company charged ahead, making gas-powered cars, but at the time, gas cars were hardly the norm. cars were a new technology, and at the beginning of the century, 40% of American cars were powered by steam and 38% were electric. Gas cars only made up 22% of the American market. Tim describes that at that time, electricity was sort of seen as modern technology because it was where all the new inventions were made. The inventions came from like the telegraph to the telephone, then the electrical grid, the radio, and then heavier than air flight. So electricity was very modern, and it would have been logical that electric cars would be the standard in a few years. The really clever thing that Ford made was that he was making cars by moving an assembly line instead of handcrafting them. By 1914, 99% of new cars in US were gas-powered. All the electric car makers had to stop because they couldn't make money anymore. And then he goes on to say that it's crazy that in 2015, when the blog post was made, we still have the same technology. So the 1815 locomotive engine looks way too similar to the 2015 car engine. So why did EVs not develop? Well, the first point he makes is that when you think about innovation, the intuitive thing would be to think that innovation just happens over time. But actually it's not that way. Innovation only happens when people really force it, really work hard to get there. And then he goes on very detailed on what the environment has to be for innovation to happen. But I think the most important thing he points out is that normally the way capitalism works is that the more real world value you create, the more money you'll make. So this should be the incentive. But the problem is that this has to be inside a high integrity, meritocratic, free market. And that's where the problem starts. He says the market should be or would have to be open, accurate and fair so that EVs could get through. But since the gas cars were already much more profitable, then it would be hard to change the technology that is underlying all of these cars. But I think the most important argument he has is that there is no incentive to make a car that is good for the environment. So basically, if the car causes harm, then it doesn't matter because there is no punishment from the outside world. So there is no reason to make EVs. And I have another quote here, I think that sums it up perfectly. In the auto industry, CO2 emissions are a negative externality. If you have a cheap and easy way to build cars that dump garbage into the atmosphere and no one makes you pay for it, why would you ever change anything? It's the same story as cigarettes. Instead of the tobacco industry and the cigarette companies who support it, you have the oil industry and the car companies who support it. He goes on to describe that for each individual actor in this whole system, the best thing to do is to keep the status quo and to keep making money with gas cars. So yeah, with all of this said, how would it even be possible to change all of this? So we come to the third part. How would it be possible to move to EVs? What is the plan here? First, to get into how an electric car even works. So you need to understand the electric motor. And the thing is that the outside part are magnetic fields and the inner part adjusts to the magnetic field. And the inner part wants to snap into the position of the outer magnetic field. But shortly before it is at that position, the magnetic field changes again and pushes it again forward. And this happens all the time. And that way the inner part accelerates. Then he describes the different kinds of cars that use electric motors. The hybrids only use a battery and an electric motor powered by gasoline. Then the plug-in hybrids, you can also charge the batteries, but it's a small battery, otherwise it uses a gas engine. And then there's also the hydrogen cars. And he goes into more detail here, but I think the most interesting point is that with an electric car, you have energy efficiency of around 90% in the end. And he says the whole hydrogen process is very complex, and at the end of all of this, you only have an energy efficiency of 20%. And then, of course, there are pure electric cars, EVs. And he says that EVs have a lot of pros. For example, that they are quieter, that they are quite convenient when you can charge them at home. And also using them when you can charge them at home is less expensive than when you have to fill up your car with gas. But there are also some real concerns. The first one is range. And he says that basically range has 3 problems. Will the battery have enough range for longer trips? Then where can I charge my battery? Where can I charge my car on the road? And then when I charge, how long do I have to sit and wait? I don't want to wait 5 hours for the car to be charged again. Then next to the range, there's also performance and price. So those 3 problems Elon Musk would have to address when he would start a company that makes electric cars. And in 2003, he decided to do it. There was already another company called AC Propulsion, which had solved 2 of the 3 problems. They put laptop batteries together and created a battery that has a car that has enough range. And then also it was very fast. The performance was very good. The only problem was that it was not a real company. It was no production yet. It was just a prototype. And Elon Musk wanted to go in there and invest money and put the product into the market, but they didn't really want to do that. But they introduced him to some guys that had started a different company, and this company was named Tesla Motors. Their plan was to license the technology off of AC Propulsion and then use this to make a product and bring it to the wide market. But there was a lot of money needed, so they had to come up with a business plan. And this was the business plan. First, he wanted to create a high-priced, low-volume car for the super rich. This later became the Tesla Roadster. Then the revenues of this will fund the development of the next car, the orange one here. It's a mid-priced, mid-volume car for the pretty rich. And then these revenues from this fund the development of this. And this is a low-priced, high-volume car for the masses. So this was the plan. Step 2 should have been the Model S. And step 3 should have been the Model 3. The Model 3 was supposed to be priced at $35,000 US. In today's 2026 US dollars, that's around $47,000 US dollars. And at the beginning, the Model 3 was not that cheap, but if we compare it to now, actually it's cheaper than that, because at least in Europe, I just looked, you can buy the cheapest Model 3 for $44,000 US dollars. But at that point, they didn't have a car at all, so they had to start with this high-priced, low-volume car for the super rich, the Roadster. It looks nice, but, well, the problem was that it cost a lot of money. And then also in 2008, the financial crisis hit the company quite hard. And in the end, Elon Musk found himself like this here, because SpaceX was also having a lot of troubles. But through some miracle that I already described in the first part of this video series, both companies survived. And at the end of it, Elon Musk was CEO of Tesla. And they also had a new chief designer named Franz von Holzhausen, who had been the design director before at GM and at Mazda. Franz von Holzhausen's first assignment was to design the Model S, which would be the Step 2 car. This model was a very big success. It had a Consumer Reports rating of 99 out of 100, and it even got 5.4 stars out of 5 stars from the NHTSA safety rating. So when it came out, it was a very successful car. They have implemented some quite innovative things already back then in 2012. Before even the first iPad came out, they had a huge touchscreen in every car. It was possible to get over-the-air updates, which was unheard of back then. Also, they had a direct-to-customers selling system. And also the performance and the battery range with around 250 miles was also really good. So if we think back about the three major concerns of EVs, it's range, price, and performance. So this car already had the performance and the range, so only the price has to go down for it to be a successful mass product. But also one important thing is regarding the range, how do you get around? They already had started to build the supercharger network of Tesla. This is how it looked like in 2015. And at the end of 2016, it was already supposed to look like this. Now, if we look at a map today, over here at the Tesla website, we can see that in the US, it's very widespread and you can basically go anywhere. And also already in Mexico and Canada, plus in Europe, as well in some other regions of the world, it is very widespread already. While back then in 2015, it was only available in the US and it was very low concentration. Back in 2015, there was also some interesting things that are now not relevant anymore. For example, they worked on a battery swap for the Teslas. They completely ditched that idea. And also the tax credit in the US was still a big factor. And now in 2026, this is also not happening anymore. So let's look at the business plan again. The first step was the Roadster, 2008. Then they developed the Model S, which was already out at the time the Tim Urban posted this. And then the Model 3 was scheduled for 2017. If we look at the numbers today, the Model 3 and also the Model Y, which is built on the same platform and is also a step-free car, they sold, in the last 3 years, they sold around 1.6, 1.7 million of those each year. So I think this was quite successful. Back then, the battery costs were really a major part. It costs around $20,000 for a battery of the Model 3. Today, a Model 3 or Model Y battery of the same size costs around $7,000. Also an interesting part is the market cap. Back then it was $31 billion, which was a lot. Today they have around that amount as revenue each quarter. So they have that amount 4 times a year as revenue. Also another crazy comparison is if you look at the amount of EVs, in January 2015, there were 740,000 EVs total worldwide. That's way lower than Tesla makes every year now. Tesla makes around 2 million cars a year, and back then there was only 740,000 EVs total worldwide. Now, what are the forces that work against the EV adoption? It's 2 big players. It's the big car companies and it's the oil industry. They will both use a lot of tools they will have in their pockets. And I think a good example of that is here, when they had scientists making studies and then deceiving the public picture. I quote again, "The same tactic was used a few decades ago when 98% of scientists said smoking caused lung cancer. But the tobacco industry convinced the public for a long time that scientists disagree about whether smoking is harmful." The book Merchants of Doubt details how many of the same pro-smoking scientists a generation later became the global warming isn't a thing scientists, the actual same people. So they used scientists to say that global warming isn't a thing and to deceive the public and to push back the date of when EVs will be widespread. Then they also spread a lot of myths. I won't go into too much details here. So now we come to the last chapter. As we saw, there are a lot of forces that work against this EV adoption. But how will Tesla succeed? What is the plan here? I think there's a good quote from the blog post where Elon Musk explains to Tim Urban the impact that Tesla will have is fairly small in and of itself. It will change people's perception perhaps, but it will not in and of itself change the world. But if large numbers of people are choosing to buy the Model 3 and the car companies see that there's no excuse left anymore, then that's what will prompt car companies to invest real money into electric vehicle programs of their own. And indirectly, by spurring competition, Tesla can be the catalyst for a multi-order of magnitude shift of the entire industry towards electric. Yeah, and I think if we look at that quote today, then we have to say Tesla kind of did it. I mean, the whole industry changes to electric right now. So that's it for today. But as Tim writes, this is what Musk spends 2 days of his week on. So yeah, he has a lot more on his plate. And with that, see you in the next part when we speak about SpaceX. Bye bye.